Well, good morning, everyone. This is Jonathan Lips, and I'm here with the HeadSpin team, and we are going to have a little half-hour webinar this morning talking about testing React native apps with Appium. So if you're just joining us, don't worry, I'll be doing intro stuff for the next minute or so you can get in and get settled and run and make that last trip for coffee if that's what you need to do. Yeah, let's take it away. So this is me here. Um, I work for a company. I shouldn't say I work for it. I basically am the entire company. I have a consulting firm called Cloud Gray. We do mobile automation strategy for primarily enterprise clients, helping them get their mobile automation off the ground and meeting whatever challenges they have. And I've been working with Appium for a long time. So I started writing the code for Appium back when it was a new thing in early 2013. So it's been, 6.5 years of hacking on Appium. So I know an awful lot about that, but had the chance in the course of preparing for this webinar to branch outside of Appium a little bit because when it comes to React Native, there are several other testing tools and methods that people tend to use. So I was able to have a look at those, and at the end of the webinar, we'll talk about how they compare with Appium and when you might want to use one or the other. So that's me. Let's dive into the first topic today, which is a brief discussion of what React Native is. And I think we all have some idea whether or not we've used React Native, that it has something to do with mobile applications and React. That's kind of right there in the name. But I think it's helpful to know a little more about how React Native apps work. So we're going to talk about that. But just briefly, the kind of motivation for React Native comes out of this fact. I suppose it's a fact. It's debatable, but there's places out there where people have done research that claim anyway that from a user perspective, native apps are perceived as faster and better than the alternatives of hybrid or web apps. And we've had high-profile cases of companies like Facebook taking their app from a hybrid version and doubling down on native. So there's certainly examples of that. And in a way, it makes sense. This is because writing native apps means using the native software development kits provided by the operating system vendors, so they have access to all of the lowest level APIs that are available on a particular device. This does mean, however, that if you're trying to develop an app and get it into the hands of both iPhone and Android users, that you have to write code for two different platforms, maintain two totally separate code bases. Basically doubles the amount of people you need to hire to get the project off the ground, doubles the amount of work you need to do. You might be able to share some design assets, so maybe it's not exactly double in all respects, but in terms of the code, it's a lot of extra work. And obviously, from a development perspective, as developers, we tend to prefer writing as little code as possible, and for good reason, because code has bugs, so we want as little code as possible. And so when it comes to writing a mobile app, as developers, we would certainly prefer to have a single code base, and we'd obviously prefer to use tools that we already know how to use. It's all, good and fine to learn Swift or Kotlin and do iOS or Android development, and that might be fun. But if we have a job to do and we're on a schedule and our skill set is in web development, we might prefer to work with web development tools. And indeed, that's the motivation for hybrid apps in the first place, and why projects like PhoneGap or Ionic or these types of things really focused on letting developers use web development technologies to produce mobile applications. And what React Native is all about is sort of giving you the best of both worlds, or trying to. It lets you target the native SDKs of iOS and Android, but using the languages and technologies that you're familiar with from web development. So JavaScript, CSS-ish styling language and things like that. So how does React Native do this awesome feat? Well, the React Native codebase maintains a set of native modules. This is code which is written in Java for Android, or Objective-C or Swift for iOS. The import libraries and frameworks from the Android and iOS development kits. And these modules run whenever you launch an app which has been developed with React Native. So these are just pure native bits of code. You didn't write these bits of code. It's part of the React Native project, but it gets bundled in whenever you use React Native to create your own app. So this is the stuff that actually gets launched whenever you launch a React Native app. And that's why the iOS and Android operating systems believe your app to be native, because it is from the perspective of the operating system. In addition to these native modules, the native modules being responsible for all the native API calls and so on, React Native apps also contain a JavaScript engine. This engine is called JavaScript Core. It's the same engine as is used in Safari, the browser. It's an open source JavaScript engine. So we've got our native modules, and also we've got now this JavaScript engine, or VM, which can run any JavaScript that we choose to throw at it. So that's what happens. As a React Native developer, what we do is write all of our app logic in JavaScript, and obviously we're using the React framework in JavaScript, although not dealing with web pages here, but dealing with a virtual DOM of mobile UI components. And all of this JavaScript is executed by this VM, which has been bundled into your application by React Native. So then what happens is these two pieces, your JavaScript code and the native modules, communicate with one another over something called the React Native Bridge. And it has its own particular protocol that it uses for that communication. But basically, what this does is it allows user interactions and feedback to go from JavaScript to the native layer and back. That means that you can code up all of your UI components or all of your user event handlers in JavaScript, but actually, in reality, they're being built and handled by the native modules. And then there's just this bridge which communicates between the two to give you this best of both worlds scenario where you can write using web technologies and yet still be ultimately targeting native platforms and using native UI components and so on. So that's all a bunch of words. Might be easier to look at it in a schematic form. So basically, we've got our two mobile platforms at the far right. We've got iOS and Android, and coupled very tightly with iOS and Android from the perspective of React Native applications are these native modules that we were talking about. So they hook in directly to the native operating system as those operating systems launch an application, just like any other native app would be. But then what's different with a React Native app and the pieces of the architecture that we have here that we wouldn't have with a fully native app are, of course, this JavaScript core engine, which communicates to the native modules via the React Native Bridge, and then we have our own app code. So in an ideal world, all we're responsible for is actually that kind of reddish-orange bit at the far left that says app code. That's what we're responsible for writing and maintaining, and that code, ideally doesn't reference anything like a UI button on iOS or an Android.widget.edit text on Android. It abstracts away all of those native UI concepts. So all we do is we write, standard React components like button or input field or whatever, and that gets ultimately rendered appropriately on whatever platform we're targeting. So this is kind of an ideal scenario where we're just responsible for writing and maintaining some JavaScript and CSS, and yet we still have the performance and snappiness of native applications from a user perspective. In reality, it's a little more complex because there's often platform-specific configuration or customization that needs to happen to make your app work exactly the way you want it to on each of the two platforms. And that platform-specific configuration needs to be maintained in a platform-specific way. So, for iOS, we have our info.plist file, which has a bunch of information about our iOS application, or for Android, we have our Android manifest.xml, which we might have to maintain little bits of information in. So in reality, what we end up with as a React Native developer is a core of shared code written in JavaScript, and then a small halo of platform-specific code that we do have to maintain. So it's hard to get away from knowing something about the native development environments. So if you're just a web developer and you've never done any Android or iOS development, you will have to learn a little bit about Android and iOS development to be successful as a React Native developer. And this is actually part of the design of React Native. Its developers don't claim that you can have purely single code base running on both platforms, but that the core of it can be shared in this one place. And then if you have any specific modifications, you can sort of keep those small and easy to update. So this is what it's like as a React Native developer. What are the pros and cons of choosing this method for app development? Well, there's a lot of positive aspects of it, and I'm actually a fan of React Native personally, and I've used it for my own app development, and I like it quite a lot. The good things about React Native are that you have mostly a single code base, as we talked about, and again, mostly no need to learn iOS or Android app development. I've learned just enough to make my React Native apps and do the kind of stuff that I do with Appium, but I didn't have to become, do a deep dive into iOS or Android app development to write my React Native app. React Native has a pretty good debugging story, so you can change your JavaScript code and then just sort of refresh your application just as you would refresh a web page. You don't need to rebuild it because your JavaScript code that you're developing can just be sort of sideloaded into a running instance of your application. Because from the operating system's perspective, that JavaScript is all just living in the user space of your application. You can change it anytime you want. So it enables some pretty interesting debugging stories. You get, again, mostly native app speed and user experience, and that's the whole point, that ultimately we're dealing with native applications here and not hybrid applications. I say mostly because, of course, you still have a little bit of overhead with the JavaScript engine and the React Native bridge. So there is that. Another nice thing about React Native is that it's extensible. If you want to do something to tie into the native operating systems that is not yet available in React Native's native module space, you can add your own extension and then just use it and share it with other people as well. The cons of React Native development are that you can tell on the list of pros that there's a lot of mosts. So it's not a perfect solution, and you do need to get your hands dirty with a little bit of iOS and Android experience to be successful. And as I said, we have this, mostly native app speed, mostly native user experience, but every once in a while, you might run into a few performance issues or design issues as a result of trying to design a cross-platform application, things like that. You're also reliant on the React Native team to update React Native whenever there's new versions of iOS and Android and to make sure that it keeps working with all those new versions. And that could be problematic. In terms of the user experience itself, this is more of a conceptual issue just to do with writing a cross-platform app using any framework. But iOS and Android, the apps are different, and iOS and Android users have different expectations about how apps should look and behave. And if you're writing one app, one UI for both platforms, you might run into problems where neither platform's user base really thinks that you know what's going on, that you know how to design for them specifically. So you might wind up in a spot where you have a lot of conditionals. If it's Android, do it like this. If it's iOS, do it like that. whether it's a visual design thing or a functionality thing. And so you might end up losing some of the benefits of a cross-platform code base by having a lot of these conditionals sprinkled in. But in practice, if you're willing to sacrifice a bit of that design or user experience, you can benefit a lot from the shared code base. And then finally, just it's good for everyone to know that React Native is owned by Facebook. Used to have kind of a shady license, actually, but as of, I think, sometime last year, they switched it to the MIT license, which is a great open source license. So you can feel very comfortable using it. But in terms of the future of React Native, it is a Facebook project, and so who's to say what they'll do with it down the road. Okay, so that's React Native. Now let's talk about Appium. If you haven't heard of Appium before, we're not really going to talk about it in this this webinar here, but just to say that it's an open source mobile automation library that people use for testing native, hybrid, and mobile web applications. If you are relatively new to mobile automation and you want to learn about Appium, I actually just released a course on starting Appium from scratch yesterday in conjunction with LinkedIn. So there's the URL there. You can check it out. It's about 2 hours long and takes you through Appium setup and all the basics. So this will teach you how to write tests for native mobile apps with Appium in general. So let's talk specifically about React Native and Appium and what is interesting or unique to running Appium tests on apps that have been developed with React Native. Well, the big reveal here is that there's actually not that much to it, and this is precisely because React Native apps are native apps. From the perspective of iOS and Android, a React Native app is just a native app like any other. iOS and Android don't know that there's this JavaScript engine that's a part of React Native, which is, making calls through this bridge protocol to the native modules. That's all kind of hidden from the perspective of the operating system. And the way that Appium works is it just uses the standard automation tools that have been provided by Apple and Google. So from the perspective of those tools, everything just looks like a normal native application. All the elements are native elements, and you can typically automate a React Native application without too much trouble, just as it is. So, just like you would start an Android test using a set of desired capabilities like this with Appium, and you'd pass in the path to your APK file. All of this is exactly the same when you're dealing with React Native. There's no special capabilities you need to use, no special commands you need to use, and same goes for iOS. If you build your React Native debug application, you can certainly load it into an Appium session using capabilities, something like this, your standard iOS platform capabilities and a path to your React Native application. Okay, so what is different? Well, the one thing that you need to worry about is making sure that your React Native app is appropriately testable. And there's just a few simple things you can do to make sure that this is the case. So here's an example of a React Native component. It's an input field, and it has a bunch of attributes. You can see that this input field has a certain style, certain placeholder text, and a function which is executed anytime the text in the field is changed. So it calls a set state on the component. This is just a very basic React pattern. The interesting attribute here is the one called test ID. So we're basically telling React Native that we're interested in this component when we're running UI tests of this application. And we want React Native to make sure to put this test ID somewhere on the native component which implements this React component, so that when we go to do UI testing, we can find the native component appropriately. And this works pretty well. If we take a look at an iOS version of React Native, so here's an application which I developed using React Native. On the left, you can see a screenshot of the application, and I'm using Appium Desktop's inspector here to inspect the native application. So I've just loaded it up, again, without any React Native specific capabilities. It's just like any other application that I'm loading up with Appium Desktop. And we can see that just by including the test ID in my React Native component, I can find the iOS component which maps to that React component because it has the appropriate name here. In other words, message input. And so I could very happily automate a test of this view using Appium by finding this element by its accessibility ID of message input and sending keystrokes to it and going on. So that's basically, very straightforward. Now let's say I loaded up the Android version of this application. So here's the Android version. I'm on a different view, but it's the same idea. We can see that there's sort of an interesting issue happening with the Android version of this application. The issue is that I have this whole list of buttons I can tap to go to different views of my application. But from the perspective of Appium, from the perspective of the Android operating system, I don't see all of these elements. All I see is one frame layout which has no children. So the children aren't available here. And this is a problem because now I can't find the element that I set a test ID on. The reason for this is that React Native for Android, when you assign a test ID to a component, it puts that ID in something called a view tag of an Android element. And unfortunately, the standard Android automation technology that Appium uses doesn't know anything about view tags. It can't access them. And React Native does this because many Android developers use something called Espresso to test their applications, and Espresso can access data inside view tags. So from the React Native perspective, you're supposed to use Espresso to test your applications, and that's why they did it that way. So what can we do to make this application testable by Appium? Well, what we need to do is make sure that in addition to setting the test ID for a component we want to test, that we should also set the accessibility label, at least on Android. Now, the accessibility label is a label that shows up to the operating system for accessibility purposes so that the operating system can make sure to surface that information to someone who's using the app in some kind of accessibility mode. And what I've done here is I've created a very simple helper function in my React Native JavaScript code called test props. And basically what it does is it takes a test ID and then returns a hash here of keys and values. One key is test ID and the other key is accessibility label. And the way that I use this on my component is instead of just passing in the test ID attribute, I pass in all of the properties that are returned by this test props function. So this is just a nice concise way of making sure that every time I set my test ID, I'm also setting an accessibility label. And of course you want to be careful here since you are setting accessibility labels to set it to something that an actual human user would appreciate reading or hearing spoken to them. So when we do this, if we reload the Android application, we'll see that voila, all of these elements which I've assigned test properties to can now be accessed in the hierarchy. So again, I could just write up a normal Appium script and test this application now without further ado. There's another strategy for dealing with this issue, and that's making sure to set the accessible attributes appropriately. So as a rule of thumb, if React Native believes that an element has an accessibility property, it won't show you the child elements. I guess not to confuse the operating system, to make sure that only one element in a hierarchy at a time is able to have accessibility attributes on it. So let's take a look at this component. Here's a component which has a scroll view and a text header and the list inside of it. So this is actually the component that defines the view we just saw here. This is the list view that we're seeing now in code. So what I've done is I've added test properties, but what I've also done is made sure that the scroll view, which is the parent element, has its accessible attribute set to false. That allows everything underneath it to actually show up in the accessibility hierarchy. React Native doesn't mask it in this case. So these are two strategies which you can mix and match to make sure that all of the elements that you want to interact with are actually findable by Appium. And that's actually it. That's really the only thing that I've come across in testing React Native applications that you need to worry about. Everything else is just standard Appium scripting. And here's just a little video of a very simple test script I wrote for my React Native application, which is obviously cross-platform, just logging in to the secret area of the application. I wrote the same test code using Appium to automate both platforms of this React Native application. So that's Appium. Let's close by briefly discussing Appium versus other approaches, because in the React Native world, people use a set of different tools for testing their apps. So one thing people use is called Jest. Jest is for unit and component level testing. It's Facebook's recommended React Native test tool. And its main kind of bread and butter is unit testing, so not UI testing, not end-to-end testing, which is the kind that Appium does, but unit testing of your JavaScript app logic. That's basically the whole point of Jest. So in this model, only your app code is tested, only the JavaScript app code is tested. All of the native modules that it connects to are bypassed, which means that no native elements are rendered, no native APIs are accessed. And this is really great for unit testing because it means that your tests run really quick. It's just like running JavaScript unit test of a website. You can get kind of one level higher with Jest if you mix it in with a library like Enzyme or something called React Native Testing Library, which goes one step further in terms of actually rendering components, but in a sort of mock or virtual way. In other words, it turns them into JavaScript objects rather than native UI elements. So it's kind of one step closer towards end-to-end testing, but still completely virtual and therefore quite fast. But of course, you also don't have the security and peace of mind of running an end-to-end test on your application, which you would always want to do in addition to any unit and component testing. But this is a great way to test many internal aspects of your application, not having to rely on Appium or some other tool to do UI tests of your React Native app, which can be a lot slower than these kinds of tests. And because this is a unit testing model, all this testing happens via the command line. There's no simulators or devices that are loaded. This is all just kind of in-memory testing. For end-to-end testing, there's a tool called Detox, which is produced by a company called Wix. And it's built on a couple other gray box testing technologies from Google. There's Espresso for Android, which is Android's kind of first-class test automation framework. And then there is a framework called Earl Grey, which is kind of an Espresso clone for iOS that Google developed. And I said Detox is gray box, which differentiates it from Appium, which is a black box testing model. Gray box tests live inside the app that you're trying to test, which means that your app will undergo modification. So if you're not using React Native, you'll have to build Detox into your app explicitly. If you are using React Native, Detox will do that for you using their command line tool. But either way, the app under test is modified to support Detox having access to the internals of the application. Why does it need access to the internals of your app? Because it wants to use Earl Grey and Espresso to make sure that your app is in a state where it can be interacted with. So one common problem with UI tests is that you try and interact with your app at a point in time when your app isn't actually interactable. A view might be loading, an element might not be available, there might be a spinner, there might be a network request. There's a lot of issues in writing UI tests for web and mobile applications that have to do with making sure that your app is in the correct state. And Detox and Earl Grey and Espresso try and get around this by living inside of your app under test so that they actually know from the app's perspective whether or not anything is happening. And they can defer the execution of any test steps until a point at which your app has stopped doing something. This makes it easier to write test scripts because you don't have to worry so much about waiting for application states. And Detox claims, and it's probably true, that it leads to greater speed and stability of your tests. And actually, Detox has special support for React Native, and it hooks into multiple layers of React Native to make sure that it waits for appropriate moments in the React Native flow for app interaction as well. So of all the UI testing tools that are out there, Detox is the one that's designed most specifically to work with React Native. So let's look at Appium versus Detox. We didn't do a big overview of Appium here. I'm sort of assuming that you know a little bit about it, but let's talk about when you might use Appium versus when you might use Detox based on the attributes that I was just sharing with you about. Well, I would argue that you should use Appium if you have a situation where maybe a QA team is writing the tests and not the developers themselves. Because of course, it might be difficult to modify the app if you're just receiving it from developers and responsible for testing it. If you want to write tests in a language that's not necessarily JavaScript, you would use Appium because Detox requires you to use JavaScript. If you want to test on real devices, Appium has a much stronger story there. Detox, I believe, works on real Android devices, but does not yet have real iOS device support. If you don't want to, or for some reason aren't able to modify the app and build in the libraries that Detox relies on, then you can use Appium because Appium is black box. It automates from the outside of your application. It doesn't need to modify it. And then, of course, if you need to test, let's say, hybrid app or a web app, Appium has a really great story with its WebDriver-based protocol of automating those other app modes. But Detox is less concerned about that. But you might use Detox if you are a React Native developer who is writing the tests yourself, because there's a really nice integration there. Or if the idle synchronization features of Detox are really your highest priorities and you just have no time for learning how to wait for app states appropriately with Appium. Now, I personally have written a lot about how to do that appropriately with Appium, and I don't think it's too challenging, and I think you can do it successfully. But there is certainly something to be said for a framework that lives inside your app and actually knows with a high degree of certainty when your app is idle and can receive new test commands. And then Detox has a really great integration story with the React Native workflow. And so if that's a need that you have, then Detox might come out on top for you. So that's basically what we're going to talk about today. Some further resources for you to take a look at. There was a great talk at last year's Appium conference on Appium and React Native by Wim Sellis. You can take a look at that. I had a lot of fun reading the React Native accessibility docs. That's how I learned some of the stuff that I shared with you today. My React Native test app, if you want to play around with it and look at the code and see how React Native app is developed, the code is up there on GitHub. It's all open source. And then I write a newsletter called Appium Pro, which is a weekly newsletter that comes out with a new Appium, tip or tutorial every week. And most of the code samples involve automation of the particular app that we already saw an example of, and it's written in React Native. So if you read the code for the code samples for Appium Pro tests, you'll see examples of automating React Native applications. And again, it's basically the same as automating any other kind of application with Appium. All right, well, that is everything. Don't forget to check out Appium Pro. And I know we are over our 30-minute time, but I'm okay to stick around and answer a few questions if the HeadSpin folks also have some time and if there are questions that are ready.
Thanks, John. Yeah, so there is actually one question that came up, which is from Carla. Should I always use test ID? Can I use class instead? I tried to automate without test ID using class and was too slow.
Yeah, so the way that Appium tries to find elements is modulated by something called a locator strategy. And Appium has a number of different locator strategies. The kind of most commonly recommended strategy is to find an element by its accessibility ID. And as we saw, when you set a test ID in your React Native application, it comes out as an accessibility ID on iOS, and then if you make sure to set the accessibility label as well, that also comes out as an accessibility ID on Android. So that's by far the easiest way to find elements using Appium with React Native, is to set both test ID and accessibility label. Appium has another locator strategy called class name, but that doesn't find an element by an attribute that you set as class on a React Native component. What it does is it finds an element by its native UI object class. So there are native UI objects called, Android.widget.editText, or on iOS, UI elements text field. And if you use Appium's class name locator strategy, you'll be finding elements by that criteria. So unfortunately, if you set the class property or attribute in your React Native component, as far as I'm aware, that doesn't make it into the native component in any way which is discoverable by Appium. So I would say that yes, you should use test ID and accessibility label when trying to make sure that your React Native app is testable with Appium.
Cool. Thanks, John. There's another question that came up. Can React Native apps be tested in web view contexts like hybrid apps?
So the answer to that is no. This is because React Native apps don't live in another context from the perspective of the mobile operating system. They actually are native applications rendering native UI components and all of that. So the JavaScript that's running in a React Native app is not running inside of a web view at all. There is a completely separate JavaScript engine called JavaScript Core, which React Native bundles within every React Native application. That's what powers the React portion of your native app, but there's no web views at all. However, you can build a React Native app that has a web view inside of it, and then anything inside that web view, of course, is running using the operating system's JavaScript engine and HTML renderer and things like that. And you can use Appium's context API to switch into a web view inside of a React Native application. But if you're just automating the native portion of a React Native app, there's no need to switch contexts to any other mode because it's just a native mode, just like any other truly native application.
Another question, I think we can take a few more. There's two more questions I see. First one is WebDriver wait class work for RN app?
It does, yes. That would be my recommended strategy using Appium with React Native. Make sure, just like with any other application you're testing, you use WebDriver waits appropriately to wait for your application to be in the correct state, whether that's an element to be present, or not present, or view to be loaded, or whatever it is.
All right. Last one I see is how much UI load synchronization related delays is there if we compare Appium versus Detox or Appium versus Espresso?
So Detox uses Espresso, so there's no, so it's the same comparison. So using Detox or Espresso, your app will be, the test will run faster and it will run without ideally needing to use any kind of wait on your test code itself. And that's kind of the benefit of the gray box testing model, as I was explaining before, because Espresso and therefore Detox run kind of in memory with your application. They're able to ask your application, hey, are you in the middle of doing something right now? Are you in the middle of downloading something? Are you in the middle of animating something? Are you in the middle of moving to a new view? And if so, it just makes sure that no more test steps are executed until the view is idle. So that tends to make tests more stable and more fast. So with Appium, you have a few different options. You can use Appium's default Android driver, which works from the outside of your application and therefore doesn't have any access to knowledge about whether your app is working on something or not. So you have to basically code that knowledge into your test script using WebDriver waits. There is actually an Espresso driver for Appium that kind of gives you the benefit of the Appium testing model, but all of the benefits of Espresso when it comes to idle synchronization and things like that. So if you want to, keep with Appium but get some of these benefits that I was sharing about with the Detox and Espresso, you should check out Appium's espresso driver. And that's kind of the state of the art when it comes to Appium taking on this gray box testing model. And there's other interesting things you can do with the gray box testing model, like interact with code inside of your application or call methods inside of your app directly without having to go through the UI, things like that. So I have a couple Appium Pro articles on the espresso driver, which you can check out to see how to get started with that as well.
Awesome. John, we'll take one more. The question is, which would you recommend, WebDriver IO or WebDriver?
I'd recommend WebDriver IO. In my opinion, it's the best maintained JavaScript, Selenium and Appium client out there, and it's got a great extension and plugin story, and is all around a really good project. So that's what I would go with.
Awesome. Well, thanks, John, and thanks for all the attendees and the questions. Sorry we couldn't get through all of the questions, but we'll definitely follow up with you guys on those questions. But thanks again, John, for all this for information, and it's always been a pleasure.
All right, yeah, thank you. It's been fun to talk with you all, and see you later.
Thanks, guys. Everybody.